Okay, for this first one, the electron configuration, what is it that we need to write up here for nitrogen? Can you give me two ways that you know that's probably correct answer? Add up the superscripts, and that tells you that it's got 7 electrons, and nitrogen has 7 electrons, so that seems good. What else? Two P3, row 2, P block, third column over. That should set it. Okay. So what do I need for sulfur?
1s2, 2s2, 2p6, 3s2, 3p4.
Perfect. So that should add up to 16. The superscript's there. Sulfur has 16 protons, so 16 electrons. And sulfur can be found in the third row in the P block and in the fourth column. So that'll work out. And iron? Excellent. So we'll have a summation for the electrons, and then we'll have the 3d6. So I know it's in the fourth row, but that's the D block, and so that's 3d. And so move over 6 spaces and you find yourself at iron. Okay. What was Hund's rule? Which one was that?
Electrons fill empty orbitals in the same suborbital before combining.
Okay. So if you've got only 2 electrons and you're trying to put them into the P sublevel, you'll just have 1 electron in each of the first 2 sublevels instead of doubling up that first orbital. And Pauli's principle?
Electrons have spin, and electrons have the same orbital must have opposite spin.
Okay. And what was the reasoning behind that?
They spell the same way, they just push.
They have a magnetic field that pushes them away. However, when they're opposite magnetic field, they are held together.
Okay, so when the electrons spin, they create a magnetic field, and if I have them spinning in opposite directions, then their magnetic fields are attracted to each other. And if they're spinning in the same direction, then their magnetic fields oppose, and they're already opposing because they're negatively charged, both. So this holds them together. How about this uncertainty principle?
It's impossible to determine both the position and momentum of the particle.
Can't take a picture.
It's impossible to determine the position and momentum of an atomic particle. What that means is
Can't take a picture of it.
can't
Photograph.
cannot look at an atomic particle particle. I don't think that's right.
That's what it says.
No, spelling.
L-E.
Is it L-E?
Yeah.
Partic. Ah. No, you said L-E.
L-E.
Okay. You cannot look at an atomic particle. Just observing or testing the particle moves the particle, affects the particle. We talked about this with temperature. If I take your temperature, your body temperature goes down. But you're so huge and you have so many particles and there is so much energy there, the amount that it went down is insignificant. But when I try to do that same thing to a single atom, that thing that's taking the measurement drastically affects the particle. Why does the shorthand notation for electron configuration go to the last noble gas?
Unchanging.
Okay.
It's the previous
Uh.
representation of it, isn't it? All the ones that follow the noble gas respond the same, or similarly.
Mm-hmm.
I like his better where it's sort of, let's just say everything, all the electrons past the last noble gas are reactive. Why can't I spell today? I don't know if today has anything to do with it, actually. So if we're looking at lithium, lithium has 3 electrons. Its last noble gas is the only noble gas, which is helium. And so of those 3 electrons, one of them reacts and the other 2 don't react because they have the same configuration as a noble gas. So anytime that situation happens, all those that have the same electron configuration as a noble gas are as unreactive as the electrons are in a noble gas. Noble gas configuration for titanium. So Ti colon back up to argon, and then I've got 4 electrons after that, so 4s2 and then 3d2, and that's it. Energy level diagram for yttrium. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d. So 1 and 1 and 1, 2, 3 and 1 and 1, 2, 3 and 1 and 1, 2, 3, 4, 5. 1, 2, 3, 1, 1, 2, 3, 4, 5. And so I'll put 2 here and 2 here and 1 there and 1 there and 1 there and 1 there and 1 there. 2 here, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That's it. Are we good with that? Questions about that? There were definitely some mistakes on the homework that I just passed back to you guys. You're gonna have to tell me which sublevels that you're talking about as you fill them up for sure. How do you know that this is the correct order here?
You can look at the periodic chart.
Just look at the periodic table. That's it. So if I'm looking at a table, open, let's look at that one. So if I'm looking at a periodic table, I've got, you're not gonna let me write in that? Seriously? Old version. Haha, that's hilarious. Yay. Cool. Let's just delete that. So I put my first pair of electrons here, right? That's 1s. And then I put my next pair of electrons right here. There's 2s. And then 2p, 3s, 3p, 4s, 3d. And you just move through, slide your way across. Each one of these is a orbital or a sublevel inside of the blocks. So it tells you which way to go. You can't go 1s, 2s, 3s, 4s, because you gotta move across the table, count up the number of protons that you're supposed to have with that. All right. Do we have any questions about this homework?